So one of the other things that we began doing in September, at the same time that we picked up the port of Pluribus, or actually before we picked up the port from Pluribus, we started investigating a workload involving GPUs. In order to do that, we needed to figure out how to do device pass-throughs that we could pass through GPU cards to guests and guest workloads. Thanks to NVIDIA and their friendliness towards hosters, we were not going to be able to run their driver blob inside of our LX containers. So what we needed to do at that point in time was figure out how to present a running Linux guest, running the blob, and present a pass-through a GPU driver, GPU card to the guest. So we got that working with FreeBSD first. And great, so now we've met kind of the requirements, but then we had the different problem of the rest of the networking stack for FreeBSD, and specifically Beehive, did not support the necessary network isolation in order to satisfy that workload. So at the time, we were largely focused on how do we create a performant network subsystem to handle the workloads that we needed to in order to be compatible with the rest of the Giant Cloud. So we all know what Beehive is, but Beehive as a whole is focused on compute isolation. It has no understanding of network isolation. This is not the fault of Beehive. It is focused on this one specific thing, which is providing a very good hardware virtualization layer. You can provide some form of network virtualization using VNet, right? But then you're in this interesting world where you're managing fibs for customers on the underlay network, and that's not actually what you want. What you really want is you want it to be able to have, as a hosting provider, you want to have one underlay network, and you want to have multiple overlay networks, one for each guest. What I mean by underlay network is a view of the world that is attached to the physical devices where packets are going to flow between servers. An overlay network is what the guest sees in order to pass packets between different guests on different servers. So how were we going to potentially map these different customer workloads and provide this network isolation layer? How are we going to do that in a performant way? So, if you've run multiple Beehive guests on the same box, using this very elegant block diagram, you're going to have two separate customers potentially on the same system. They've got their compute isolation. You have a network device, and somehow you need to pass this along. Well, if you wanted to have two guests on the same server talk to each other, you can do that using bridge. Great. You create two tap devices, you plug them into a bridge. Other than the fact that that performs terribly, you've got some form of network isolation for just two customers. And so that works, right? Like, it's slow, but it works. And the only reason we know it's slow is because we did it, we benchmark it, and you're only going to probably get 8 gigabits or so a second. And there's a bunch of reasons for that, but that's insufficient for the level of performance that we need. GPUs are extremely expensive. Extremely, extremely expensive. And so that asset, you want to have at 100% utilization at all time. And if you're going to be doing training and other ML workloads, you're going to want to move large amounts of data onto the GPU host and then move the resulting data off the host, which means that you are basically fire hosing information at a server as fast as you can, processing it as fast as you can, and getting the results off as fast as you can so that the next chunk of data can come onto the box, and the GPUs are at 100% utilization. The size of the data sets are large. It's not uncommon to saturate 25 gigabits plus worth of throughput in order to make this happen. So performance was a particularly important thing, and why we quickly identified that bridge was not going to work. In the general case, we needed to also be able to satisfy how do you connect customer workloads out to the network. Right? So you can potentially chain interfaces together and chain bridges together. Other than the fact that this continues to get worse in terms of performance, this can also work, or something to that effect. So problems, right? Like I said, tap and bridge are slow. They work, right? In a pinch, they get the job done. but they're insufficient for what I will call commercial virtualization. The other one is like, how do you ARP, right? If you've got this overlay network and you've got a guest running on server A and you've got a guest B on server B, how do you potentially pass traffic between the two, right? How do you perform some form of an ARP lookup? How do you do your VXLine endcap? Right? So we invented this new subsystem. And I'll explain what VXLine is in just a second. But we invented this new VPC subsystem. Right? VPC, as a subsystem, is a collection of different pseudo interfaces that plug together. So instead of passing tap devices into guests, we pass in VM NIC devices. You plug a VM NIC into a VM switch. You plug the VM switch into a VM, or that should be VPC link, into a VPC link, and the VPC link then wraps the device and sends an encapsulated packet out over the network. When the VPC switch receives a broadcast packet, it traps up to userland using KEvent to let you know that there is an unhandled ARP request, and you make a write back down to the kernel and inject the packet back to the guest so that you have some form of ARP resolution for guests that are running up here, because you can't handle ARP down at the physical underlay layer anymore. Right? Same thing happens for v6 neighbor discovery. So this is the problem. How do you get traffic from customer B to talk to each other? How do you get crosstalk over your network? So we use this thing called VXLine. And so what you do is you tag individual customer switches with a particular VNI, VLAN network identifier, or VXLAN network identifier, and traffic from VXLAN 987 can see each other. VXLAN is effectively, if you're familiar with VLAN tags, VXLAN is the IP version of VLAN tags. Instead of having the tag in the Ethernet header, you've got the tag in the IP. You actually encapsulate the entire Ethernet frame. So you can potentially have VLAN tags running inside of a VXLAN encapsulated packet. So we call the process of taking a customer packet, sending it through this whole chain. This is encapping the packet, and then decapping the packet, passing it through to the guest. So this subsystem can do this, and it does it at extremely high data rates. So VXLAN, it's just a preamble on the packet. It's, I think, 20 bytes. I have to go look again. So it does kind of play with some of your NTU there. But really, mentally, you can map VXLAN to VLAN tag packets. So yeah, so you can pass traffic back and forth between the two guys now. There we go. There's a number of different pseudo interfaces that we created in order to do this. They're all they're pluggable where appropriate. So at the top layer, we have this thing called VPC switch. It switches packets between different guests. You can plug switch ports into, then you can create VM NICs, and you pass those off to guests. You plug a VM NIC that you plug into a guest into a VPC switch port. You take the VPC switch port and you plug it into a switch, or more correctly, the VPC switch. You tell the VPC switch go grow a switch port, and then you plug the NIC into the switch port. And the reason we do that is because we're about ready to add firewalling support on a VPC switch port basis. And then your VPC switch can have an uplink interface. You plug in a VPC link interface into your uplink, and now you have kind of end-to-end connectivity for guests, because now you can take a network interface and pass it through to a guest, have the packet flow through to endcap at the last possible moment before the packet goes out over VPC link, because you don't want to do endcap, decap, if you can avoid it, if you're talking between, let's say, two guests on the same hosts. Right? That makes no sense. And so now, as kind of an end result to this, is you can pass traffic, and that's exactly what we wanted to do. How do we do this? Well, we invented a couple system calls in order to call into these subsystems. Most notably, we wanted to, or importantly, we wanted to use kind of conventional Unix idioms. So you open a VPC descriptor, you control the VPC descriptor, so very similar to a read-write interface where you can perform operations on the different types of VPC objects. Each VPC descriptor maps to a single VPC object so that you can control individual objects at a time. One of the things that we ran into as an interesting aside is if we wanted to make something that was capsicum-like. capsicum and manipulation of network interfaces is kind of problematic because once you have some AFnet privilege from capsicum, you can go and take those privileges and apply them to any interface. You can't scope your privileges to a particular device, and we wanted to do something that was a little bit more fine-grained than that. And because we have this existing infrastructure that is very UUID-centric, Giant makes excessive use to its benefit of UUIDs, but they're everywhere. We have used UUIDs as the primary user interface for looking up all of our data structures. So going forward, we've got a couple of other items that we're going to be rolling out. We're also going to be upstreaming this. This is all open source. But we're going to be integrating IPFW and attaching that on the VPC switch ports. We have routing slated so that we can go in and move packets between different subnets. And then NAT, so that we have some concept of an internet gateway for ingress or egress. We're doing some additional work on the tooling. More on that, you can ask me about that later. And there's one more that I'm missing right now that I remembered just a second ago, and then the train left the building. Anyway, we have the code available. It's under the project's VPC branch. We have the kernel libraries, all written in Go, are available here. And then the userland tooling right now needs to be moved once it's polished up to standards, but we have the userland tooling available. And that said, we have questions.
From IRC.
Yeah, go ahead.
Let's see. Is Join doing anything?
We have a microphone too,
yeah,
in addition to questions. Is Joyent doing anything regarding suspend and resume? And also, what can you tell us about brand hooks?
We are not doing anything with any of those on the FreeBSD side of things. So, pretty easy to answer. Or at least, not that I'm aware of, not at the moment.
That might be a question for me.
Oh.
Brand hooks is Join, or Luma's brand.
Oh!
Yeah.
There we go, sorry. I was like, we're not doing it. Go ahead.
Yeah, here we go. Okay, let me look. I have a big document on this implementation. So the hooks have to do with like automatic creation of Phoenix. There's a specific Beehive brand that's been created. Like there's the Linux brand, things like that. So there's shell scripts that are called during the stages I talked about, the state changes, like booting or booted or halted. But I think this is just Join Illumos specific right now. This isn't upstreamed yet. And they do need to be rewritten, Mike says. Yeah, there's a couple things they don't support yet, but they're just trying to get this stuff out the door. Does that answer? Is the person who asked the question here? Does that answer the question?
They're on IRC. We'll see what they say.
So what kind of like external toolings are you working for? Because you mentioned like there's a bunch of toolings out there, like most are routing in shell script.
Yep.
So what specific stuff are you looking for and you want to develop? Because you are not alone in this.
Okay, so this is, I'm going to put on my personal opinion hat real quick for just a second. Do not write tooling in shell scripts, okay? And if you, go look in the mirror and please do not write tooling that you intend to be mature tooling as shell scripts. Okay? This is one of the frustrations and aggravations of looking at and using Beehive. So yes, we are writing a way of launching Beehive instances using, in the control application that I mentioned here, VPC VM run, or VPC VM create, VPC VM run, in order to manage the life cycle of individual VMs, and we'll plumb the VMs all the way through into their correct VNI, into the right subnet, so that when you launch a VM, it's in a network encapsulated environment, and you have you are managing a fully encapsulated unit of compute that includes compute and network. So yeah, that's where this is, and we're going to be doing more work likely on that, but that's the gist of it, and that is all written in Go, and a little bit more robust than a shell script.
I'm writing the, sorry. I'm writing the Beehive part, like creating, stopping, listing. So if there's anybody who has like a sort of a Beehive wrapper that's already written, like I'm interested in that, because I'm currently figuring out how I want to implement starting the VM, because there's so many like configuration options and building that big command.
Yeah, because actually I've been working. Because actually, but I mean early stage. Actually, I've been working on an external tool. I'm gonna talk a bit later. Also to manage VMs, because now it's very complex. Beehive is a complex software, right?
Mm-hmm.
So like I think everybody's quite tired to type a shell, a command line like this size with so many options. And I'm doing something with Go also.
Okay.
Yeah, so I got a lot of things outside, get the specification, but I'm in the early stage. I think it will be great, like if we can talk later.
Right there.
Definitely.
Patch is welcome.
Yeah.
Yeah, it would be nice if, we're not going to do this, but it would be nice if somebody came along and did a Versh shell support or compatibility layer in order to launch Beehive VMs using some of this interface. So,
Like, I wonder if it makes more sense to have something like a libbeehive, that you can have wrappers in Go.
no,
whatever language
no,
you want,
no,
which is
no,
like Beehive.
absolutely no. Why? Because then you can't cross-compile. It requires the target, it requires access to the header information of your target platform. We have bypassed all of that with this interface. I'm happy to go into details, but definitely no. You don't want to have to write a tool that conditionally works whether or not a kernel feature was enabled or not, right? This was one of the largest problems when working with Nomad, the cluster scheduler, trying to target all of the random idiosyncrasies of the target platforms, because now you very profoundly interrupted the developer workflow when trying to work on platform A targeting platform B. You had to go and spin up individual instances of platform B and do all of your cross compiles with a myriad of different instances running for each one of the different versions. That was incredibly painful. We should learn from that and definitely not do that. syscalls 580 and 581 are going to be put up on Fabricator for review, and we're going to homestead those syscalls. Absolutely not libbeehive. If you want to do that, call syscall 580, 581 directly, but there's version support in those syscalls so that we can potentially version the semantics without having to rev something using libc or lib whatever. Definitely not.
Well, I was just wondering for more the actual creating the Beehive instances, other than the VPC stuff.
Sure, yeah. Okay. No, sorry, yeah.
For the VPC stuff.
Maybe a strong response.
In a more single host configuration,
Yeah.
can you opt out of the VXLine part and just have the
Yes.
switches and then out to the...
Ooh. This is one of the neatest things that's coming down the pike. I'm really excited. I'm very excited about this. So, in this workflow, okay, if you have imagine this is your laptop, okay? You want to spin up a guest. One of the things that we have, because all of these network interfaces are composable, actually, you'll find a different slide that had the right names.
Or that one.
Yeah, except for that, again, that's VPC link.
Yes.
So if you have a VM NIC running your Beehive guest, you're going to plug into a switch. You have a switch that's going to have an uplink to a router interface, because it's router. It's going to have a default route to a NAT interface that will then hit a VPC link interface, and then, or to an ETH link interface, which is a different type of interface that I didn't talk about, and then it will send your packet up. The reason we did that, and I'm very excited about this feature, is because right now if you want to go and create a VM, or provide network encapsulation and isolation for applications running on any server, any laptop, any desktop, whatever, you have to provide all of this network plumbing a priori to your guest. And that's an enormous pain in the ass, right? It's doable, right? We actually have a Packer Beehive implementation, but you have to statically define the IP address and the network and everything else. With NAT, when that's done, then you can just spin up a VM, you create some random VNI, you assign it to the guest. There's no end cap because it'll send out an untagged packet, but it'll go through NAT for you. I'm very, very excited about this.
Can you do it in more of a bridge configuration without the NAT?
Yeah, that works right now. You can do switch VPC link to an ETH link, and then it goes out with uncapped. That was the link that I forgot to mention that I was springboard. We had another kind of a VMI. I think that's what we called it. VPCI, that's what it was. VPCI. And that is used for jails, so that you can get a VPC interface that you can plug into a switch, and you pass that VPC interface to a jail, so that if you wanted to go in and have some encapsulation for a jail, you can actually get that and go through this virtualized network stack.
Right, you can hook a jail up to
Yes.
switch one to be
Yep.
in the same network.
Yep.
as the
And so that was, yes, that was the other one that I forgot to mention.
Sean,
Yeah.
the question continues with how does this compare to the existing SmartOS crossbow and Fabric's overlay on SmartOS?
This is very similar to Lumos Crossbow, largely inspired by the intentions of that framework. So, you have one more question about also. Go ahead.
Is anyone working, and I'm totally on the side of stop shell scripting for provisioning.
Yes.
Is anyone working putting Beehive into Vagrant as a provider?
Beehive is a Vagrant provider? Yeah, we actually have, we have some work. One of my coworkers has done a bunch of work for generating Vagrant VMs. This is another very interesting use case for this, because there is both tangent. There's this thing called Vagrant, it makes it very easy to create VMs. There is a Vagrant Beehive. Interestingly enough, the reason the Vagrant Beehive is not fully baked is because of all of the work involved in and dependencies on PF and other things in order to bridge a guest network with the host network and the underlay network. All of that complexity goes away after this. I'm very excited about it. That said, we have done a bunch of work because we've been doing a bunch of BSD testing in order to create Vagrant VMs. So using current. You want another rant? I'm going to tell you, don't use stable, only use current. And so you can go and create a Vagrant box using current very, very quickly now. When you do a git init, you git clone git init and pass it a SHA, it'll go and create a Vagrant box for you using that particular git SHA off of GitHub FreeBSD.
I've got a question, general question. Did you consider using some open source software which exists actually?
Like vSwitch?
Open Contrail, I was thinking of. Because what I can see is very similar concept, and having Open Contrail will give you all tooling, all configuration for free, only missing one piece like kernel module.
So, not opposed to integrating with that. We were mostly interested in doing the kernel interface and the kernel bits. I didn't mention this, but we're able to pass traffic guest to guest at 78 gigabits using this. So that's why.
Someone arrived late and is asking from a high level, why FreeBSD?
Yeah, so the question is like, how does this differ? I think he's talking about FreeBSD VPC versus Lumos Crossbow. How does this differ from Crossbow and Lumos and Fabric's overlay on SmartOS? And what was the main driver for switching to FreeBSD and writing all of this stuff?
So we haven't, yes.
Yeah, there's no switch.
Right.
These things are going on concurrently.
Yes.
So it's very, they're both very similar, but
in order to kind of hit the timelines that we had, because we got because we got GPU working for pass-through as a working solution, we need to figure out the network component of things. A lot of this work is still ongoing. How does it compare? There's very different semantics in terms of configuration and administration between the two. At the end of the day, you've got tagged or uncapped packets coming and going off of the network, and that's fundamentally, at the end of the day, the issue. We have, or the result. We have done interop testing in order to make sure that everything is protocol and standards compliant, so that guests running on the two different platforms that are passing VXLine traffic are able to pass traffic. So
yeah, and then the most important takeaway is that they're both the teams are working on these two things concurrently.
correct.
There's not a switch.
Yep.
Any last questions? Thank you very much.